I would prefer that you put it in your book of truth so that you're not, I mean, so it's in yours, you know, rather than you're just thumbing through bunches of papers.
But can I just staple it all into my papers and then I have everything in here?
Now, I'll live with that. That means you've done something, right? All right. Is Ben here or is he taking his quiz? Ben, we're going to take our quiz next 10 minutes.
Or maybe even attach my papers.
No, he's here.
I'm here.
We're taking our quiz.
Okay. When will you send me my quiz?
It should be up right now.
Okay.
I think I made it live at 1:30.
I see it. I'll take it now.
Yes. Ben, you doing okay?
Yes.
Everybody here is already done.
Oh, okay. I just printed it off, so I'll have it to you.
Yeah, I
Um,
figured it'd take you some time. Good? You guys need more time? All right. Easiest quiz yet?
Yep.
Better than.
Oh, I have to-
All right. McKinley's, let's grade his. Yes, 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 no, no, yes. Your markings are in the wrong spot, but it's the right answer. Yes, yes, no, no. So three wrong on the front.
Yay.
Yes, 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 yes. Change it. Yes. 2, 3. Yes. Okay. Everything on the back's right. 3 wrong. All right. I got your something or other. You get a car. You get a car.
I want a car.
You get a car. You get a car. And Jack, I gave you back yours this weekend.
Oh, I got one.
Yeah.
Uh-oh.
You already know what you got.
Yeah.
I let him grade his own test.
Oh,
He gave himself not an A.
no, I got an A. I got low A.
All right.
How did I get the proof? So
Question on the.
I turned, sir.
Yes.
I turned my thing in.
Thank you. Question on page 1?
20 of 10. 10, please.
No?
10, please.
10, please. What?
Please go over number 10.
Yet. All right, page 2. Questions? Number 10. I'm looking at the test, Ben.
Oh,
So-
never mind.
Never mind. You're talking about homework, I assume. All right, page 2, questions? This is going to be quick. Page 3.
Oh, okay. I see what
Wait, there's a third page.
There's 4 pages on the test.
Wait, I only got 2.
No, not the quiz. The test. We're going over the test.
How hard is this?
Extremely.
Jack
No, I did not.
didn't do the. I thought you did the proof right.
I did the proof very much wrong.
Oh, very wrong.
I
You got it right.
missed a step.
She missed one step.
I'm
Kind
I
of.
don't know.
And yours was no.
right now. So this is.
All right. I mean, that's all you really needed was that, and you would have been done.
But I
And that was a
still
pretty
got an
good. I mean, literally,
Oh,
this is how many steps. That's it.
okay.
There may be another way of doing it, but this is how I would have done it. You know. We will get better proofs.
Right.
Yeah.
Why was the board to potato?
No idea. 7th grade stuff.
But
I told Miss Boyd she can have that board except for that part, and she can write whatever she wants, and I won't erase it.
No, she can write chicken.
She can write potato apparently, and it doesn't make a difference because I didn't.
Are you regretting our decision not allowing to erase it?
No.
No? Okay. But it's a potato. We only get potatoes in Russia. I think.
What? Where did potatoes come from?
They came from
South America. Potatoes, tomatoes, llamas. What else?
basically anything that's good came.
Guinea
from-
pigs.
What? How did I not get this?
I don't know.
Hey, at
So-
least you got some points right. I think I just failed at this one.
You failed the proof for sure.
But I still got an A. That's better than the last 3 tests.
Yeah, because
What did I do?
Ben, I don't know. It's on your look on Teams. Why is this not sharing? Sharing's caring. Come on, thing work.
Are you playing on your calculator?
No,
then?
94. You got better than me.
You got a 96. Oh, wait, I just missed one that off. Dang it.
The proof.
No.
Proof's worth
I got
10
93.
points.
I got 93% on this. That's why.
Why are you not working?
Oh, it's on freeze.
Well, yours is on freeze, but Ben's is not. It's not
What do you
allowing me to-
mean?
Well, it's telling me that it's not sharing. I don't know what you see on your end.
I see what I saw the thing, but then you just took it down.
Let's see. Oh, yeah.
Okay, now it says you're sharing.
I see the screen.
But then when I go to,
You messed up 2 things. Yep.
do you still see it or not see it?
I still see it.
Okay. Do you see it now?
I get a better.
Yeah.
Do you see the calendar?
No.
Yeah, for some reason it's not sharing.
Uh-oh.
Literally, I wasn't even.
What about now?
Like, I was looking
Yes.
Okay, that'll work.
It's just the weird black thing where I get all the insight information.
Yeah, I haven't made it. You're seeing the presenter's view. Now I'll change it to the other view. All right, copy down your homework.
Do you want to collect ours or do you trust?
Oh, wait, we got to go over. Thank you. Yeah, let's go over homework.
Number 10, please.
So you
I'm not saying.
Yeah, Ben, we know. I'm pretty sure I got this one.
I'm pretty sure I did really good.
I think I just got lazy near the end and just wrote what I thought. Hold on.
I didn't have enough room on number 10, so I had to like.
All right, so this one isn't in 3 dimensions because it's not colored. So I got to draw the picture, Ben. That's complicated.
Yeah, that's what I had to do.
Number 10 was really long.
It was,
Yep, I
it
definitely
It wasn't
got
that
this.
hard, it was just a lot
It
of
wasn't
steps.
hard, yeah. It was just that. That one I did, yeah. It was. I tried to do it in as little steps as possible.
All right,
Yeah, I
LM is congruent to LN. KM
Making great and
and KO bisects.
MN.
And MKN.
KO bisects.
MKN.
Okay, so that's congruent to that.
Uh-huh.
Okay, and we're supposed to show LO bisects MLN. LO LMN. So we need to show basically that. So I need to show that MLK, angle MLK is congruent to angle, what's the other one? NLK, is that right? Look that right?
Yeah.
Okay, that's what I gotta show. All right, but I don't have it yet.
Martin Luther King Jr. is congruent to Martin Luther King Jr.
Yeah,
Arthur Luther. Who the heck is Arthur?
okay. What do we know?
Well, I can, okay is congruent
So-
to okay.
When I get some weird thing, and this is mostly to you, Ben, when I get something weird like this, I draw the triangles that maybe I could say something. So there's lots of triangles in there. Clearly, if you look at the bottom 2 triangles, the medium ones, we can get an SAS out of that immediately.
Yeah,
See that?
obviously.
So I'm just going to go ahead and put 3 tick marks on MO and NO.
And that's wait, why?
But the hard part is the fact that you have 3 pieces of information and you have to take one of them out and you can still solve it. Which one of the 3 is it?
LO is congruent to LO, and then you can do SSS, and then you can do CBCBC.
That's what I would do.
Yeah, that's what I
That's
would
what
do.
All right, so now let's talk slower so Ben can hear us. So Ben, the first step I did was just simply say that MO is congruent to NO. Well, actually the first step I would have to say is that KO is congruent to KO reflexive. And then I could say that triangle MKO is congruent to triangle NKO because of SAS.
Yeah.
Once that's done, I'm going to say MO is congruent to NO by CPCTC. Then I'm going to say that LO is congruent to LO by reflexive property. And then I can say by SSS, those 2 triangles, And then finally, the last two angles congruent. And then by definition of bisector, that the two that L bisects MLN. Okay, so yeah, bunch of steps. It is number 10. It's in the B. As soon as they get to B, they get a little bit more challenging. Yes.
Can you do number 6?
6.
Uh-oh.
Exercise 5, we got to prove the converse. So it's got this. We don't know what the shape is, but it's probably a parallelogram.
Well, I thought we did.
We do know what the shape is. You use the same shape for both.
But quadrilateral. No, but I'm saying we can't call it a parallelogram because we don't know what a parallelogram is yet.
But we do know what a parallel is.
Well, sure, but it's the geometry game.
But what is geometry? You already know.
So we know that S, S, K, R, N. And obviously my diagram is pretty horrible. SK is congruent to NR. And we know that SN is congruent to that.
This is a little bit harder.
And we need to prove that this is parallel to this and
So
this is
then,
parallel to that.
so then we do reflexive property, and then we do alternate interior
Okay, okay. So, yes, what he said. So, reflexive, then I can show that this triangle is congruent to this triangle, side, side, side. So then I can say anything. So, here's the big question, though, is you got to convince yourself that we want to say that 1 is congruent to 3, but maybe 1 is congruent to 2. You're not guaranteed. So, we gotta do the triangle congruency statement. So, if I say triangle SKR, I mean, granted, it's probably true, but we just got to convince ourselves. I'm going 1, 2, no name. So I got to go 1, 2, no name. So that's R and S. R and S. Now, does that give us that 1 is congruent to 3?
Yes.
So that would be S is to R. Is that right? S is to, okay, so
And
we
then
can say that.
congruent to 2, and then if alternate interior angles are congruent, then the two sides are parallel.
I wish I could speak that fast.
Yeah, you're going to get into problems, Jack. You're going to like call yourself an aneurysm or something.
Oh, I can't wait till you're in college.
Allie,
Someone
yes,
walks
no?
in and is like, hey, that kid talking fast.
Okay, anybody else?
Then you put on
Yes.
fake teeth.
7 and 8.
7 and 8. All right, let's take a look at 7 and 8.
I like 7 and 8. They're fun.
I think
So
I
you got
lazy
these mountain-looking
yesterday.
things.
Ugh, I'm like,
And A, M, B.
Oh yeah, I spent like 15 minutes on each of these because I was like so confused.
And D, E. Number 7, we're told that this is parallel to this.
So we chose a
So immediately, if this is parallel to this, what can you tell me about this angle and this angle?
corresponding angle congruent.
So I
It
get
took me a long time to
that.
figure that out. And
Okay.
then we know that
And
AMD is congruent
We
to
also could say that this angle is congruent to this angle.
and then
alternate
you could say that angle
Hold
that
on,
one is congruent
hold
to
on,
angle
hold on,
B,
hold
and
on.
then you could say
And then we have that this is parallel to this.
so then AMD.
Yeah, they're two
AMD
So
is
this one and this one,
Yeah.
by corresponding.
So we could prove this by AAA, but there is no AAA.
yes, there is. We just haven't learned it.
We need to get a side in here somewhere.
Yeah, well, the side you can use is the midpoint formula for AM.
No,
and
I'm
MD.
leaving off the other part which says that M is the midpoint, so therefore that's congruent to that. We got ASA.
And then we can.
Okay, so what were we trying to prove though? We were trying to prove that
That
MDBE,
MD is congruent.
MDBE, yep, done. CPCTC. And then if we're given, now I gotta erase everything. Then if we're given that this is the midpoint, this is 8, and we're told that ADME, I need 2 tick marks, and ADME, so once again, we would have that angle is congruent to the angle,
So then SAS.
then we got SAS.
And then you can prove that they're parallel by corresponding corresponding angles.
Right, then you would have to show, we were trying to show that
AMD
MD,
AMD is congruent to.
I got to show that this angle is congruent to this angle. So by CPCTC, this one is to that one. After you say SAS,
And then they're parallel.
and then they're parallel because of the converse to whatever that theorem is. So that if alternate interior angles congruent to the lines parallel. And that was it. Is there anyone we didn't go over?
We didn't go over 9, and we did not go over 5, 4, or 2, or 3.
Or
Or
one?
two.
I'll take a look at all that. All right, so let me have your homework.
Can I do math today?
Can you do math? That is always the question. Can you do math?
Well, I could do math. We could get a gigantic pyramid and I'll figure out the math of that. I just don't back it up real quick. Okay.
Well, they would be too.
All right, so that's what the homework. Nothing left this week. I fully anticipate that we will have to do a review. We probably won't get through it today because there's only basically 15 minutes left, and that's why I couldn't get it through with the other class either. All right, homework, if we get to it. And I would also say this, don't think that you have to try your homework if we don't get through the whole thing because there's a lot of theorems and corollaries today.
Oh, no.
We have porta potties now.
They're perfect.
They are.
Why are they-
I've never seen a purple.
You're not going to miss it.
Yeah, now I can
It
probably.
sounds like a religion.
Ben, you're missing all the fun of seeing the construction start.
Well, who says I'm not there in the blue car at the end of the driveway?
Where's your sister?
She's
saw her-
Yeah, she's
saw her
currently
at
in
the-
gifted and talented because she's a special child.
Oh. Is he really out in the parking lot?
Sometimes he is.
Last week?
All right, here we go. Recall from the last class, to show two parts of congruence, either two angles or two sides, it's this basic technique. You show that those two parts are part of two different triangles. Tell me that the two triangles are congruent. Tomorrow we'll get AAS if we, in fact, get through this class. If not, then it'll be on Wednesday when we finally get AAS. And then lastly, call CPCTC. And finally, to show that if two things are parallel, right? Not two angles, but two sides. Well, show that those two sides are part of two different triangles. Once again, show those two triangles are congruent. Call CPCTC, and then claim alternate interior angles. So here's the new stuff. You need to, I'll leave it up to you whether you want to write it on this or put it in your book of truth. Right? Isosceles triangle. If you already know what it is, maybe it doesn't need to go in your book of truth. The triangle where two sides are congruent. So there you go. This always reminds me of Oogie Boogie, whatever the character was named. It looks like to me.
You mean the Nightmare Before Christmas?
Yeah.
Kind of character?
Wait, what?
It looks like him, Oogie Boogie.
Oh yes, the weird spider
Yeah.
creature inside.
Sack guy or whatever. I don't know. Isn't it Oogie
Boogeyman?
Boogie?
His name is the Boogeyman.
Yeah, but I thought he was called Oogie Boogie.
He says Oogie Boogie. His name is the Boogeyman because that is his official name in all of.
Doesn't it look like him, Jack? Ben?
Look like what?
Miss Kittle used to do that to us all the time.
The isosceles triangle. Doesn't it look like him?
Kind of.
Okay.
All we need is a
I can
mouse.
see why
Right.
you think it looks like him.
I
Now,
can see it.
there are parts to this. We are going to call the angle between the two congruent sides, this angle right here, we're going to call that angle.
In between the
It's the included angle, but we're going to call it,
in between.
wouldn't that make sense? We call it the vertex angle.
Oh, the math always.
And they are going to use these terms. It's not that bad to memorize, but just in case. And just remember, it's the angle between, the included angle between the two congruent sides. We have names for the two congruent sides. They're called,
Exterior congruent sides.
no, they're called legs.
But why are they called legs?
I don't know. They're called legs.
Then the bottom one is the bump.
No, they would be the bottom of the feet, the soles of the feet. You know, if those are the legs, and that's the foot.
Well,
But
it just looks
how
like
would
it
this
just
thing
looks like he's
walk?
sitting down.
No, this is his
If
head.
that's his legs.
This is his head.
Wait, what?
His
Then how
head.
is the sides of his head?
The reds are his
He
eyeballs.
is very deformed. He's like a genetic mutant.
Right.
If he has legs on
The
his
bottom
head.
we're gonna call the.
Base.
Okay.
Mm.
Okay.
Now you got to be careful because it's not the bottom; it's the side that's opposite the vertex angle. Because we could turn it sideways, and then it's not on the bottom anymore.
But then it would become the vertex angle.
No,
But it's still in
the
between
vertex
legs.
angle is between the two legs.
Yes, but the base is also in between the legs.
Oh, I got you. So the vertex angle is the only angle that is between. It's the included angle, or the angle formed by the two legs.
But
How
how
about
do you
that?
figure out which one's vertex angle? Does it have
The
to be
angle
one?
formed by the two legs.
But the base is also by the two legs.
Yep.
The base is not an angle. It's a side.
Well,
Correct.
it could be an angle.
No, but he is right. We do have two angles down here. What are we going to call these two angles?
Opposite
They're
angle.
they are the angles that are opposite the legs. True.
Yeah.
Well, it might be, might not be.
I-
We're going to call those the base angles.
What doesn't
I have a question.
Yes.
Would the base angles always be would always equal each other?
Good question.
Um,
I will give you an answer after the proof.
Okay.
obviously, yes,
All
I
right.
bet money on that.
All right. Now you do have to be careful, and they are going to use all three of these words, or four of these words: base, vertex angle, legs, and base angles. And then also be careful that the base angles are opposite the legs. You know, if you take any one of your legs, you look at the angle that's opposite, it's called a base angle. And what? Hold on. And then lastly, although this is always the diagram that we see with isosceles triangles, but remember it could be turned sideways, both ways. The base doesn't stay on the bottom, it moves. It's always opposite the vertex angle.
Yes, but then it's the vertex.
Yeah.
It's the second vertex then.
Yeah, no, we don't call it that way. So in other words, the notation of isosceles triangles is indicated by the two congruent sides. So Ben had a statement. He said that it looks to me like the base angles should be congruent.
They are.
They are.
Well, we got to prove it. We can't just say
But
that.
how can
Wait, did Ben read ahead?
Probably.
I always thought that because if the legs were always the same,
Not because it's in the book, then it must be true.
yeah,
Right?
the
Yeah.
writers wrote-
that's what I thought.
How about we prove it? All right. So
How
here's an
about that?
isosceles triangle.
Well, it's clearly side angles and side.
Yeah, but remember
Yeah.
we need two triangles.
But no, you don't. You can do one. It's still side.
Yeah, but
Yeah,
it's not
but-
congruent. It's congruent to itself.
Yeah, it's like BAC is congruent to BAC.
All right. So here's the start and here's the finish. And I just want to say, what is it literally saying right here? So if you need to show that two things are congruent, what's the basic technique?
Reflexive. No, not reflexive. Substitution.
What's the basic technique to show that two things are congruent? 3 steps. 3 steps. What are the 3 steps?
Change those numbers to A.
Show that the triangle.
Show that those two parts are part of two different triangles.
They're part of one.
Then show me that the triangles are congruent, and then claim CP/CTC for those that could not remember that.
Draw another triangle.
Yeah.
So our problem is we don't have two triangles there. So how can we fix that?
Draw
Another
another one.
triangle.
But what if you have terrible
Triangle
handwriting?
EFD.
Right.
Very terrible.
So I'm just going to show you where I want you, and I'm going to make it even more more rules, right? I'm going to say let's not just draw, go from A straight to the bottom. Let's do it specifically. Let's make it a bisector of angle A. Let's bisect angle A when we do this.
Oh.
So I'm going to construct the bisector AD. So in other words, I'm going to bisect A straight down, and we've got to have a D, so there's your D.
Okay,
Oh,
makes sense.
that makes sense.
Okay.
But then if it's an angle bisector, then we know that those two are congruent. and then
Oh,
we
stop,
know that-
stop.
Yeah,
Ah! You're ruining the class.
Sorry.
Don't think so fast. Give everyone else a chance.
Well, if
You can think as fast as you want, but just don't give everyone a chance to think about what.
Well, now you can do BD is congruent to DC.
Say again?
BD is congruent to BC.
Oh.
Okay, hold that thought. But before we do that, that's the part that Jack was yelling and screaming and going 400 miles an hour. We got to say one thing before all that.
See, my point is, if I speak to you, that's nobody can.
What's the consequence of being a angle bisector?
You have to make it a bisector.
Which ones? Are. Okay.
But
Let's put that statement in there.
bad CAD. What the heck is a bad CAD?
That's when your CAD drawing is really bad and it makes bad stuff when you hit print.
Can we do bad CAD next time?
Maybe. All right. Okay, so let's mark what we got so far. We got this right here. Now, McKinley, what do you want to say?
BD is congruent to BC.
Well, we got to do something before that.
But they are congruent.
But then
That's
you
the
couldn't prove that
given.
Because then you would have ASS.
Oh, I'm sorry. What you were saying was something else. We can't say what you're saying because we don't know yet.
I do know.
What can you tell me about the dotted line?
A dotted line. Congruent.
So therefore, we could say by the.
Right.
Oh, I already put markings. What do you mean? So we can say that AD is congruent to AD by the reflexive. Now, McKinley, before you say that BD is congruent to CD, you got to say one other thing.
It's a triangle.
Keep talking.
CCC.
Keep talking.
CCCC.
3 steps. Step number 1, show that the parts are to 2 different triangles. Done. Step number 2,
CTPC.
that's step 3.
Oh, that is? Okay. Well,
Step number 2,
make it congruent.
show that they're congruent. Why are they congruent?
Because of the congruent. Because of angle side.
Now you're just throwing out things. Why are those 2 triangles congruent? Look at it. Don't look at me.
Well, they're just clearly congruent.
Why?
Because of a postulate.
We only have 3 of them.
Oh, yes, it's a postulate.
And you just literally took a quiz on it.
Well, they're side angle side.
They're side angle
That's what I
side.
was trying to say. I just said angle
All right.
side.
I know, but
instead.
that's wrong. Right. So yes, side angle side. And now we can claim.
That is congruent to C by C.
Okay. So notice it falls, and I'm saying, I'm not lying when I say this is like a third of the proofs in the book, just like this. Or this is part of it. So eventually we get to, more complicated ones, but it still uses this as part of the proof. Show me that the parts are part of 2 different triangles. Show me the 2 triangles are congruent, and claim CP,
So
CP,
can I
CP.
just make a theorem that says all this in one?
We can. So what does this theorem say? If
If 2 sides are congruent,
of a,
then they're base triangle. Of an isosceles.
so basically, if you have an isosceles triangle, then what?
The
2
base angles are congruent.
The base angles are congruent. That's what Ben was saying. This is called the isosceles triangle theorem. And it says that if you have an isosceles triangle, then the base angles are congruent.
I just know that from common facts.
Well, we just proved it, by the way. Now it is a common fact in this class.
But it's always been a common fact.
I don't think we've ever talked about base angles with isosceles triangles. We've talked about isosceles triangles. We haven't talked about base angles. So this is our theorem, and no one remembers 4-1, so we just basically say the isosceles triangle theorem. And the ones that have names, they're used a lot.
Like the Pythagorean
Right, exactly, and that's why it has a name.
or the McKinley theorem, which says everything's right because it is.
Which says that at some point during every class, McKinley will say something.
It's correct.
It's
That
not
is wrong.
that is right and wrong at the same time. I don't know.
That is off topic.
Yes, that's the McKinley theorem right there. Easily proven. All right,
What about the Jack theorem? What does this say?
that he will talk 100 miles an hour.
Yep, I'll take it.
Okay.
All right,
What is the
Remember
Mr. C
corollaries?
theorem?
Mr. C's theorem, I said that if I teach you about a theorem in class, you will be using it to do your homework.
What if I don't want to use
theorem.
No, you'll be using these for homework. Okay, corollaries, remember, we get them from one specific theorem. In other words, I'm about to give you 3 corollaries from that one theorem right there. Leaves on a tree, so to speak. They don't have names. They're all called corollary 1, 2, 3, 4, 5. So they all have the same names. That's why you have to say it's corollary 1 to a specific theorem. So, and we have to prove these, and these are all easily proven. It's not really part of the definition of a corollary, but most of the time, corollaries are easily proven. So this is going to be corollary 1 to the isosceles triangle theorem. And it says this: if you have an equilateral triangle, it's also equiangular.
Well, that's common.
Yeah, but that doesn't say anything about a isosceles triangle. Why? It
Because
says equilateral.
But an equiangular triangle is also equilateral.
Right, but what does that got to do with isosceles? This is a corollary to the isosceles triangle theorem. I thought you were about to say the correct thing.
Oh, okay. An equilateral triangle is also
And
isosceles
it has at least 2 sides. Now, we don't say it is an isosceles triangle, but it certainly has 2 congruent sides. So here's how, watch me prove this real quick. You ready? All right. Let me cover that up. Guess what it looks like now?
triangle.
What kind of triangle?
Right triangle.
So what do we know about isosceles triangles? The base angles are congruent. Okay, you ready? Turn your head to the left. Left. What do we got?
an isosceles
And
triangle.
therefore, those 2 are congruent, and there you go. Done.
Wait, no. But you could have.
This would give us that's congruent to that, right?
You could have a isosceles triangle that's not equiangular, right?
Yes, true. But not the other way around. Right.
Wait, what?
Not the other way around, but the way you said it, yes.
But it's.
You can have an isosceles triangle that's not equilateral.
So there's no such thing as an equilateral triangle. It's just a regular triangle.
What?
So an equilateral triangle is just a regular triangle.
What do you mean by regular triangle?
It means that they're all the angles of the same angle.
That's called equilateral and equiangular.
No, wait, but you said it was regular.
We can say regular as well too, for that matter. Okay, can we get on this? So there's corollary 1. That if you're equilateral, you're also equiangular. How would you use this? You'll say you have an equilateral triangle, therefore you already know that all the angles are the same. Okay. One other thing that we get from this, you can probably make the leap of faith on this. So it's equiangular. So what? What would be the next statement if I told you it was equiangular?
Then it's equilateral.
True. I don't know if we actually proved that, but that is true.
If it's equiangular, then it's.
Well, we can prove it really easy, but
If also
not
equal-
until I give you one more theorem.
Equilateral triangle. There.
If all the angles are the same,
Then it's.
It's equal to each other
okay, keep talking.
because of
I thought you were about to say it. No, we don't have that yet.
then
We
the
will
base
after the
is-
next theorem.
Base 2 is.
How about all the angles are equal to?
190.
60 degrees.
60.
That's corollary 2. Well, if all equilateral triangles are equiangular, and by the triangle angle sum theorem, whichever one that one was, maybe it was corollary as well, we know that all the internal angles of a triangle add up to 180 degrees. Or we could use that other theorem that says polygons, the internal angles are n minus 2 times 180. Well, if they're all equal to 180 and all 3 are the same, then 180 divided by 3 is 60. So not much going on there, but that's where we get proof for that the angles are 60. Now, you might argue that we already have this, and I agree. And we literally had a formula that said that if you want to know the internal angle, it's n minus 2 times 180 divided by n, which would have told you 60. All right, this is the most important one right here. Right? It says this, corollary 3. It says, if you have an angle bisector of the vertex of an isosceles triangle, that angle bisector is a perpendicular bisector of the base. Ends up being a
obviously.
perpendicular. Well, you got to prove it.
Why?
Well, you're given this. Now tell me why it's a perpendicular bisector.
Because you have SAS and then you have that they're equal to each other and then they're perpendicular
Because why?
CBCBC.
No.
Why not? Well, because it's
They're
just a
congruent.
straight line.
Why is it
It's a straight
perpendicular?
line from the vertex angle.
Well, how do you know it's straight? Prove it.
Because it's a line. That's the definition of a line.
No.
Lines cannot be curved.
You agreed, but
Definition of an angle
that ain't
bisector.
perpendicular. This could be an angle bisector right here, and that's not going to be perpendicular.
True. Well,
So why is
definition
this
of-
one perpendicular? You're almost there, by the way.
Because it's a straight line and the two sides are the same, and then
Whoa, whoa, whoa. What'd you say?
the two sides are the same.
What two sides are we talking about? We're talking about
This one and this one.
perpendicular angle. Why is it perpendicular?
Because the other ones are.
Oh,
both
period two
45.
got this pretty quickly too, by the way. What?
They meet at 90.
Why?
Because they're perpendicular.
What? Nowhere in here did it say make a perpendicular bisector. It just said do an angle bisector. Okay, so I bisect the angle. Why is this 90?
Because you said so, the book says so, the
Ja-
triangle says so, the laws of triangles.
What's the deal about the two triangles?
They're congruent.
Okay, so by CPCTC, they're congruent and
And because
no, easier than that.
Yeah.
Why is this 90 degrees?
Because 90,
You said by CPCTC, what about these two angles?
They're congruent. Because the measures are the same. So they're 90.
No, they could be 60 and 60 and they're congruent. Why is it 90?
the other two are 60 and 30.
You don't know that.
They're 45 and 45.
It could be 10 and 20 for all we know. Straight line.
Yeah, it's a straight.
Straight line right here, not the red dotted line. The base is a straight line.
The red dotted line is a straight line as well, though.
I don't care about the red dotted line. I care about the black line, the base. If it's 180 degrees and these two angles are congruent by CPCTC, that's why they're 90. That's where we get perpendicular. Where do we get the fact that these two markings right here, where do we get the fact that these are congruent?
Because of CPCTC.
Because of CPCTC. So if they're congruent, therefore they have the same measurement. So that same measurement, therefore that dotted red line must be a bisector of the base leg right there, base side.
but it's
And then
clearly
if it's
90 degrees,
bisector.
it's not tipping anywhere. It's not the-
Yeah. But remember in geometry, we can never visually look at the diagram and get an angle
But
measurement.
that's how our eyes see the world.
Oh, I agree with that, but that's not how we do geometry. I agree that it visually looks like it's 90. All right, so that's the most important one, is that we got to take a step back and think about this. How did we make this construction? What did we do?
We made two sides the same.
What did we start with?
A triangle.
What kind of triangle?
Isosceles
If
triangle.
you start with an isosceles triangle and you finish
Make a bisector to
of
the
the,
vertex angle.
you actually make a,
A two congruent triangle.
you actually make a,
A perpendicular
read it.
bisector of vertex and isosceles.
You make a perpendicular bisector of the base side. So that's what you got to remember. And this one we use a lot. Most important one. There's a lot going on there. A lot going on there. All right, perpendicular bisector. What time we get out of here?
I think it's
40?
like 40.
All right, we can get through one more. All right, one more proof. So this is what you wanted me to say. You wanted me to say that if two angles are congruent, then it's isosceles. Well, this will be the converse, right? Well, let's see if we can prove this. This was harder.
Okay. Well, we can draw a bisector.
First off, what are we trying to prove?
That AB is congruent to AC.
If I'm going to try to prove that two things are congruent, what's the basic idea? Always.
To get them to be congruent, to get two congruent triangles.
Show that they're part of two different triangles, show that the triangles are congruent, and then claim,
Draw a bisector. of
CPCTC.
BAC. Draw a bisector of BAC.
okay. Let me catch up. So he wants me to draw an angle bisector of BAC. Okay, done.
Okay, and then
No, let it catch up.
Then AB.
Now let's label what we got. What do we got now?
Side angle side.
Now what do we got because of it's an angle bisector?
ABD.
You got two triangles.
Say it again, McKinley.
ABD is congruent to AC.
That's the given. That's the given.
Wait, no, that is.
It is. B is congruent to C. That's the given. So BAD, so we're back to bad CAD, right? We get that because that's the definition of angle bisector. Now what?
And then we also get AD is congruent to AD.
Reflexive, okay.
And then
What does that give us? Anything? Does that give us what we want?
no,
Yeah, that would be what angle, side.
which is true.
Which is true, but we haven't proved it yet.
But CDA is congruent to BAB
CDY,
because of Corollary 3 to us.
which says
2,
what?
3, and 4, 1. The bisector of the vertex of an isosceles.
We don't know it's isosceles.
We don't know it's isosceles.
Otherwise, we could definitely, that would be a good one. Okay,
Okay.
this is a hard one. You're not gonna get this. You ready?
Wait, but what if we draw that BD is a,
Easier.
D is a midpoint to BD?
If two angles of one triangle,
Are congruent to 2 angles of the other.
what are you gonna say about the third?
That they're congruent.
So if this is congruent to this,
Then AC is congruent to BA.
then what? If this is congruent to the what, then what? It's ASA, right? It's ASA. Why? Because it's called I call it the two-angle triangle theorem. It has a different name. I want to say it's, I don't know, Theorem 3.5 or something like that.
Theorem
It says-
5 is alternate to your angles.
All right, that's not that. If two angles of one triangle congruent to two angles of another, then the third angles have to be congruent. That gives us ASA, finish the proof,
Then because of CPCTC.
because of CPCTC, then you're done. Now, you do have to make that triangle congruency statement, though.
So no homework tonight?
It's a
Yeah.
corollary.
Okay.
It's a corollary to,
Corollary 1 to theorem 311.
that's it, corollary 1 to 311. That's what, it says if two angles of one are congruent to two angles of another, then the third angles are congruent. No, but you got to flip through your book of truth to find that sucker. All right, we'll finish it tomorrow. I got no further with this class than I got with period 2 either. This is literally where I stopped as well.
There's so many obvious things. I could prove this without using any proof.
You can't use magic, McKinley.
But I use magic. I could be a wizard.
Are you trying out for the play, McKinley?
No.
You could be a crazy good character.
There's some really cool bisectors. Like a minotaur and
Run around with a cow bull's head? That'd be
a
awesome.
lot of things that are snaky and fishy. But I can't think of what they're called. A lot of spandex. That'd be great. Oh, that's right, amigos. Hi.
Should I leave?
And we'll stop it right here.
Okay, goodbye. I've submitted the
All
homework.
right. Sweet. See you tomorrow.
You too.